In the second session, we discussed about the basic concepts of congruence modulo n, and we solved some simple problems to calculate the remainder or the value of x. Now, in this session, we will continue with some more examples and the problems like find the least positive integer when 2 to the power of 50 is divided by 7. So, 2 to the power of 50 itself a big number. If you divide by 7, what will be the remainder? Okay, so before solving this problem, I will take the theorem. So it is already proved. The theorem statement is if A is congruent to B in mod n and C is congruent to D in mod n, then A into C is congruent to B into D in mod n, that is a product, as well as the sum or difference A plus C is congruent to B plus D in mod n. So this is one theorem, so that we will use to solve this problem. And one more thing is, as the basic definition of A is congruent to B in mod n, so here, so B should always less than n. If it is more, then we can divide B by n, and whatever the remainder, that we can enter here. So now we'll come to this problem. So 2 to the power of 50 if divided by 7, then what will be the remainder? So that is 2 to the power of 50, so is congruent to some number, say x, in mod 7. That is, if you divide 2 to the power of 50 by 7, okay, so say k times, then what will be the remainder? So that is nothing but x, that we have to calculate. Okay, for that we will use this theorem. So before that, you just give the powers to the 2 such a way that 2 to the power of 1 is equal to 2. So you divide this number by 7, then the remainder should be 1. If it is 1, it will be easy to solve. So 2 to the power of 1, it is since less than 7, we will increase the value, that is 2 to the power of 2, that is 4, 2 to the power of 3, that is 8. So here, when this number 8 is divided by 7, we will get the remainder is 1. So 7 and 8, if you divide 7 ones are 7, then the remainder is 1. So how we can take 2 to the power of 3. 2 to the power of 3 is congruent to 1 in mod 7. Okay, this is a trial and error method. Go on, give the values to the power of 2 such that whatever the number we will get, that number if you divide by 7, mod 7, because the question is divided by 7. So you divide, then the remainder gives 1. So in this case, 2 to the power of 3 is congruent to 1 in mod 7. Now I want 2 to the power of 50. You multiply the number to the 3 such that it should be nearer to 50. So that is 2 to the power of 3 to the power of 16. So that is 2 to the power of 48 and is congruent to 1 to the power of 16 in mod 7. So same way. So this gives 2 to the power of 48. 2 to the power of 48 is congruent to 1 power 16 is 1 in mod 7. This I will take it as equation 1. Now I want 2 to the power of 50. So 2 to the power of 50 means I want here the power 2 square. If you multiply 2 square both sides, so that is 2 to the power of 48 multiplied by 2 square is congruent to, or I will solve separately. I will solve separately. So 2 to the power of 2 I required because 48 plus 2 is 50. So what is the 2 to the power of 2? 2 to the power of 2 is equal to, or is congruent, or is equal to 4. Okay, is congruent to 4 in mod 7. That is, if I divide 2 to the power of 4 by 7, since it is less than 7, so no need to divide, we can keep as it is. This I can take it as equation 2. Now, using this equation, A into C or A plus C. So, product if I take, so 2 to the power of 48 from 1 and 2, from 1 and 2, 2 to the power of 48 multiplied by 2 to the power of 2 in the LHS is congruent to equation 1 RHS, that is 1 into equation 2, it is 4 in mod 7. So finally LHS become 2 to the power of 50. 2 to the power of 50 is congruent to 4 in mod 7. So nothing but if you divide 2 to the power of 50 by 7, we will get the remainder is 4. Therefore, R is equal to 4. Now we will consider one more problem. Find the remainder when 2 to the power of 1000 divided by 13. So as usual, 2 to the power of 1000 is congruent to some number, say x mod 13. So if you divide 2 to the power of 1000 by 13, so what will be the remainder, and that x we have to calculate. So as I told, 2 to the power of some number, you just give the values to the power so that it should give one number which is divisible by 13. The remainder should be 1. So either it should be a positive 1, plus 1, or minus 1. If you enter or if you get that number, it will be easy to solve this problem. So let me try the power one by one. So 2 to the power of 2, 3, 4, it will be what will be the number if you divide by 13. So up to 2 to the power of 5 we will not get that accurate answer. If I go with the 2 to the power of 6, so that is equal to 64. So once you divide 64 by 13, okay, so 13, so that it comes 13 fives are 65. So you will get the number is minus 1. So either plus 1 or minus 1, I can go with 2 to the power of 6, that is. So 2 to the power of 6 is congruent to minus 1 in mod 13. Now the power, you multiply to the number for the 6, that is raise the power both sides such that it should nearer to 1000. So that number is 166. See, if 6 multiplied by 166, we will get 996. This number, it is again trial and error method we have to work out. So 996 will come. If I try with the 6 into 167, it gives 1002. 1002 means it is exceeds, this value exceeds the 1000 whatever our question. So you stick on this number 166. So what I will do, just raise the power 2 to the power of 6 to the power of 166 is congruent to minus 1 to the power of 166 in mod 13. So either minus 1 or plus 1, if you raise the power, you will get the same. Even minus means if it is an even power, it becomes plus. So 2 to the power of 996 is congruent to, we will get 1 in mod 13. So now the next is what I want for the 1000. I want 2 to the power of 4. If I multiply 2 to the power of 4 here, then 996 plus 4 gives 1000. So I am using this concept a to the power of m into a to the power of n equals a to the power of m plus n. That is the basic theory of indices. So for that, what is the 2 power 4 we will calculate. 2 power 4 is 2 power 4 is equal to 16 actually, but 16 is more than 13. So if you divide 16 by 13, so that is 13 ones are 13 and the remainder gives 3, nothing but 2 to the power of 4 is congruent to 3 in mod 13. So this is equation 2. Now from 1 and 2, the equation, that is from by the theorem from 1 and 2, 2 to the power of 996 multiplied by 2 to the power of 4 is congruent to 1 into 3 in mod 13. So finally 2 to the power of 1000 2 to the power of 1000 is congruent to 3 in mod 13. That is the remainder. If you divide 2 to the power of 1000 by 13, we will get the remainder equals 3. In the next session, we will solve some more examples on this congruence modulo n.